Hello everyone, today we'll be doing homework 7YT. Homework 7YT asks us to write a function that returns a list of all prime numbers less than or equal to 1,000 with digit sum of 10 using by importing two functions from previous work, digit sum of and its prime of. And then the second question was to generalize that code for every for a lower and upper limit and any ds, where ds stands for digit sum. And the third one was an extra credit question that we were supposed to print out a nicely formatted table using these criterials over here. So here's my code for it. I have primes le 1000 ds 10 over here, and for I in range 1000 plus 1, for I dear sum I equals 10 and its prime is of I, prime print I. So basically what this does is it iterates from 0 to 1,000, and while it does that, it checks if the digit sum of that number is equal to 10 and is a prime, and if both these conditions are satisfied, it will be that will be printing out that number. And take notice that I'm importing these two functions up here. Now I'm also importing a few more, and because I'm importing them using this symbol over here, I don't have to type them up over here followed by a dot. The next question was to write a generalization of that code, and over here I have it over here. Lower, upper, and ds as parameters. For I in range upper plus 1, as you can see I just subbed in upper for 1,000, and now I have three conditions to satisfy, and these two are very similar to this one. And as you can see I just subbed in ds for 10, and I have I greater than or equal to lower as another condition, and if all these three conditions are satisfied, I will be printed out. Take notice that I can have lower in here if I wanted to, but I chose not to, just for fun. The extra credit question was to print out a nicely formatted table, and I have it over here. I have two different codes that do the same thing basically, but pretty similar. So over here I have it printing out digit sum and number of primes with that digit sum with a nicely formatted style, and I'm also printing out hashes, as you can see, with also a pretty nicely formatted style. And I'm running this loop function over here for p in range 1 round 9 times log of upper divided by log of 10 plus 1, and this basically gives a range for that sum digit sum that I need, and this has pretty good logic to it, and it stems out of the fact that if you have 10 digits, which means the upper limit is 10, you're gonna have 9. The maximum sum of digits you can have is 9, and if you have 100, the maximum sum you can have is 18, which is 9 plus, which is not 99, and which is gonna be 9 plus 9 is gonna be 18, and this is what this stems out of. And if you can actually see, if you put 1,000 in here, if you put 100 in here, it will be divided by 10, by log of 10, and the log of 100. Since this is a Python, log of 100 will not really be 2, because log of 100 actually means ln of 100, and I don't know how to calculate that in my head right now. But since it's gonna be an ln, to change the base I divided by log of 10, and I'm going to multiply that to 9, and then I'm going to add by 1, because I wanted to keep that I wanted to include 9 as well. So over here I'm printing it out for with a nicely formatted style, pretty similar to these ones, and I'm printing out p comma p, and in the second spot I'm putting out a number of digit sums primes advanced. This code down here is the same thing, but it's using another function program over here. As you can see, I have two some very similar but a bit different functions, and I want to mention that both these functions are actually like the same thing, except these they are using the data from two different functions. So this will be going from lower, upper, p, and p as parameters, and basically this one is will do the same as well. but these two functions are the ones that be controlling it. So over here we have the two functions. This function is pretty basic. We are setting lower greater than lower equal to 2 if lower is less than 2, because there's no prime numbers less than 2, and if we include 2, that any number less than 2, it might cause some problems. And it also cuts down runtime. Over here I have a counter. I'm setting it to 0. So I have a loop function going on here for n in range lower, comma n plus 1, where m is the upper limit. So I have two conditions to satisfy, which are digit of sum of n equals p and is prime of n. And if both these conditions are satisfied, the counter will be going up. And this will be done, as you can see, for each p, and p will be each of the sum numbers, the digit sum that this will be generating. This loop function will be generating, and that's the basic idea behind this. And this will be using the functions that I'm importing. The next one is a little bit more complicated. This one is using a dictionary, and I'm also using a counter, and I'm also using the same kind of strategy over here to get rid of that less than 2. And I'm also running the same kind of loop over here, but where it diverges is on the next line, where this goes for k in checker dot values, and checker is this dictionary that I'm creating. So k will be each of the values in checker, and checker right now is 0. By 0 I mean it has nothing in it. So when this code first runs, there's nothing in there, so whatever number that will be 1 will be inputted in there. And I'll talk a little bit more about that later. But right now, looking at this, if k is less than n, because we only care about the k's that are less than n, if n is divisible by k, this if function and this loop, of course, will break, and it will get another n to test out. And we need it to be less than n, because we don't really care about any other k, because we're looking for prime numbers, and a prime number is defined as a number that has all the numbers below it, not as factors of it. And they will be factors of it if they're divisible. If n is divisible by any k under it, it will be divisible, and that's why this break function is here. Also, if this loop function doesn't fail, this is executed, and as you can see, this else function is for this loop function over here. And this loop function, when this else function is executed, checker of n equals n, and if digit sum of n equals p, the counter goes up. And as you can see, I'm just checking in this dictionary before I divide, make sure that it's a prime number, and this checker will be all filled with prime numbers. And since if a number is divisible by a prime number, below it, it's not a prime number, and so this will be cutting down some time, some runtime, because I'm only dividing with the important numbers below that specific number. And this will be returning a counter right here, and they will be returned in these two functions. And we'll see which one is going to be faster. And I have these main functions over here in a way of measuring that, and I'm importing it from a time module, as you can see. I wanna talk about a little bit more about what I found out. What I found out was I expected this one, number of digit sum of primes advanced, to be faster for any input over here, but it turns out that this one is actually faster. But I noticed that this one gets slower as time goes on, and this one has a constant speed, and we'll be able to see that when I run this. Now let's add up this to 10,000 so that the effect can be seen. So let's run this. So this one is the one using the dictionary. As you can see, it has a pretty constant speed. And this one, as you can see, it started pretty fast. It's slowing down, and it speeds up at the end. And as you can see, this one is a lot faster than this one. But I suspect that it's time, as if I push up the number more and more, this will be executing at a slower pace, because it will need to divide the number by each of the numbers below it, and while this one only has to divide by the prime numbers below it. So this one I believe will come out top if the number that we are putting in this function over here is greater than 10,000. And I've tried it for a greater number, but my machine is not able to handle it, so too bad. So thank you for watching this video. Until next time, see ya.